Alright, so this is our second proof dealing with angles. And in this proof we're given much less information. We're just given that BD bisects ABC. We can get a lot of information from this picture, so don't forget to use your pictures. So our first statement should be that BD bisects angle ABC, and that is our given. So we should think about next, going off of our given, is about what bisect means. And to bisect something means to split it into two equal parts. So if BD bisects angle ABC, then we can say that angle 1 is congruent to angle 2. And that's just by definition of a bisector. So anytime we are given something bisects, we should think about what that means in as far as each individual angle and being able to set things congruent to each other. So a lot of you would probably get stuck at this point. But next you should be thinking about your picture and what it's giving you. So what you should eventually be able to see is that there are several different sets of vertical angles in this picture. So we know that vertical angles mean that they are across from each other when two lines intersect. So in this case, we can say that angle 2 is congruent to angle 3 because they're vertical, and that angle 1 is congruent to angle 4 because they're vertical. And that's by the vertical angles theorem. And vertical angles are always congruent. So that's what that theorem tells us. So after that, we can say, okay, so if 1 is congruent to 2 and 2 is congruent to 3, then we can say that 1 is congruent to 3 by the transitive property. Once we have that 1 is congruent to 3, we want to get that 3 is congruent to 4. So, and we've already said that 1 is congruent to 4, so we can actually substitute 1 out and put 4 in, and we get that angle 4 is congruent to angle 3 by substitution. But we don't want that 4 is congruent to 3, we want that 3 is congruent to 4. So, we need to go ahead and switch those, and anytime we switch them, we do that by the symmetric property. Now, if we had switched something up here, then there's a chance that we wouldn't need symmetric property. So you just need to look at what your proof is doing and use what you need based upon what point you're at. Just because your proof is different than mine does not necessarily mean that it is wrong.